And so we just got finished talking about the Tully-Fisher relation and how it can be used to measure the distances out to 1 billion light years away from Earth, but that's not far enough. So now we want to go out even further, and you notice that I drew a line here because these two techniques are useful for measuring the distance from the Earth to a galaxy, but now we're interested in knowing the distance to a nearby galaxy cluster, clusters of galaxies, and we want to know the distance to those. So in order to be able to do that, we're now going to use a standard candle. And do you remember when we talked about supernovas and we said that they were so bright we could see them in other galaxies when they occur? So there is a particular type of supernova that occurs with white dwarfs. And so if you have a white dwarf that's in orbit around a star, that white dwarf can siphon off hydrogen from the other object, and then that white dwarf gets enough mass that it blows up as a supernova. And we have calculated how much energy would be released in that supernova, and it turns out to be approximately 100,000 times the amount of energy per second that the sun releases. So that is a fixed number that we know about. So now we're going to look at a galaxy that is in a galaxy cluster. And in that galaxy is going to be a white dwarf that is going to undergo a supernova event. And so we can measure the apparent brightness of that supernova using a photometer, and then we know that its real brightness was that 100,000 times the brightness of the sun. We know that. So now we've got two pieces of information. We got the L and we got the F, and we can plug it into the photometry equation and solve it for the letter R. And so this particular technique is going to be good up to 10 billion light years from Earth. We can use this technique. But this method is not going to be useful for distances greater than 10 billion light years, because the supernova then would be too faint to be seen. So we're going to need one more technique in order to figure out even further distances, and that's going to be the Hubble's law. So here is a sample question just to show you how to use the equations in order to figure out the distance to this object. And so now we're going to take a break, and when we come back we're going to talk about Hubble's law.